Hey guys, welcome back. Today's lesson is on slope and parallel lines. Our mindset message today is that math makes sense. I just again want to remind you that, you might be going through it and things can be challenging and hard, and when you're in the middle of it, maybe it doesn't make sense and you really have to work hard, but math does make sense and you can do it. Our learning goal today, pretty much one thing. We want to be able to use the slope of a line or two lines to determine if they are parallel or if they're not parallel. Okay, so if they're parallel or if they're intersecting. And our prior knowledge, it's good to be able to find the slope based on a line's equation, and there's different ways to do that. It depends on the form of the equation. Our next one is writing equations for lines. So it's important we remember what we've learned a few lessons ago with how to actually write an equation for a line depending on what information is given, and then using the right format. And then of course what we've been learning just this recent lesson about systems of equations and those methods and what it means will be helpful for us today too. So let's revisit the end of last lesson. We were given this system of equations, and when we tried to use substitution, we made these equal and we solved it, we found out there's no solution. Now remember, when we say there's a solution, it means that's the location where the lines cross each other. So this means the lines don't cross each other. They do not intersect. Now, one important thing we've learned recently, you should recognize this form, and just for a reminder, the number with x here is always the slope of the line, and this number here in this format, right, if this equation is solved for y, then this here is the y-intercept, right? Now notice something here. This line and that line have the same slope as each other. Now this should make sense to you, because if we were to think about these two lines and graph them, this one y-intercept is at 4 and the other one at -1. And let's just kind of draw it so it looks like they have a slope of 3. That's approximately correct. So I didn't do a perfect job drawing this out, but if you were to actually look at the graph of this and this, notice the only difference is their y-intercepts. So their angle or their slope is exactly the same, it's just that one of them crosses at a different place than the other. And if they have the exact same slope, which means they're just going up in the exact same way, it makes sense that they would never cross each other, right? And this is the core idea behind this lesson today. So let's dive into some more examples here. So this brings us to an official definition today. Two lines are parallel if they have no points in common, and we know this also means that they don't intersect. That's the main definition of parallel. Now, this definition has some consequences based on our study of lines and slopes recently. So we have two main rules for today that are related to each other, and we call those theorems, remember, in math. So if two distinct lines, that just means that they're different lines from each other, have the same slope, then they must be parallel to each other. Okay? Same slope means they never intersect. And if two lines have different slopes, then they must intersect. And furthermore, they intersect at exactly one location. So that will form the foundation for what we're going to look at today. Okay, so the core idea that we're needing to answer questions about is this today. Identifying if you have multiple equations, identifying if the lines are going to be parallel or if they're going to intersect. And technically, if the equations happen to be identical, but maybe just different versions of each other, you might want to check that, because that means they're actually just identical lines, okay? So take a stab at just pausing right now and answering these really quickly for yourself. And remember, in general, we want to identify the slope, and if the slope is the same, then they're probably parallel. Now, if the slope is the same and the equations are exactly the same, that just means they're identical, okay? So check that yourself right now. So let's check our answers real quick. These two slopes, while they're related, they're actually reciprocals, but they are not identical. So that just means the two lines must intersect. And remember, the number here attached to x in this format is the slope. Now this one's not quite ready. This second equation, to find the slope, we should probably move this x over to the other side. But when we do so, we see that this is the same as y equals 3x plus 4. So it turns out that equation and that equation are actually identical equations, and so that just also means they have the same exact line as their graph. And then last, these are parallel, because that slope and that slope, even though the numbers are technically different, those two slope ratios are actually equal, so identical slopes. Okay? So that's the basis of this. There's one more type of thing we need to be able to do though with this. Let's do one more, and we'll call it part D here together for number 2. We want to identify these two as either parallel, intersecting, or neither. Now, both of these are not quite in the right format to identify the slope. Now, actually, there's a couple of directions you could take here. If you wanted, you could just simply find 2 points that fit each equation, and then use those 2 points to find the slope. Or you could just rewrite each equation into a familiar format. And the easiest way is solving the equations for y. So let's actually solve each for y, and then we can use that right from that equation we get in the result to identify what the slope is. So what I'll do here is, I wrote these equations side by side so I can just work downwards. And to solve this one for y, I'm going to subtract 4x from both sides. And what I'll get here is y equals, and remember we typically, when we want to use slope-intercept form, we leave the x part first. So I'll write it as negative 4x plus 11. Now guess what? This is ready to identify the slope. We can see the slope is negative 4. On this one, I'm going to subtract 12x from both sides, but I'm not quite there yet. I'm going to leave it as negative 12x plus 18 here, but I'm not done solving for y. I need to do one more thing here, and that is dividing both sides entirely by 3 so that I've just got y equals over here. So again, you see we subtracted the 12x over to there, and then we divided by 3. Now, negative 12 divided by 3 gives me negative 4x, and 18 divided by 3 is 6. So this equation actually becomes negative 4x plus 6. And guess what? This and this have the same slope, and they are not identical lines, because this is plus 11 and that's plus 6. Their y-intercepts are different. And so what's our conclusion here? These are parallel to each other. So sometimes it's a little trickier, but still not too bad. So here's the very last thing we're doing today. We want to be able to write an equation for a new line that's parallel to a given line, but then passes through a specific point that's told to us. And this is where we need to remember how to write equations for lines, right? So we're going to revisit some of our different things we've done, and we're going to work through this together. Now, just to remember, when we see parallel, always remember that means same slope, right? So the good thing is, we can identify the slope, hopefully, of the given line. In this case, look, we know the slope is 1/4. But we want to go through the point 2, 5. Now, if you remember, there's a very specific format for an equation of a line. We often call it point slope form that does this. If I'm using that point, remember, y minus 5 equals slope times x minus 2. Remember that. 1/4 is the slope. So remember, this goes through the point 2, 5, and it has slope of 1/4. So that means it's going to have to be parallel to this line. But then we know it also, we've constructed it so that it goes to the point 2, 5. Now for this next one, the slope isn't immediately available yet, but this one's easy to solve for y, right? So we can rewrite this as y equals minus 2x on both sides. So we have a negative 2x plus 6. And so we can tell that when I write my equation, I need it to have a slope of negative 2 so that it's parallel to this one. Now this point given, this one's different than this point. This point here was just some random point. We had to use this point slope form. This one's special because we know whenever x is 0, this point is going to be the y-intercept. So we could write our equation in slope-intercept form, which that's the form that looks like this solved for y. So we could write y equals, well, we need to be parallel to this, don't we? So we need to have a slope of negative 2. So negative 2x, but what is the y-intercept? Negative 3, right? So if I know the y-intercept, generally that's going to be the easiest way to write the equation. If you really wanted to, we could use the point slope form, because that's not a problem, and we could just do what we did there. In this case, we'd have to do y minus negative 3, which actually is plus 3, remember, equals negative 2 times x minus 0. So this one or that one, both would be acceptable, but maybe the quickest one for this would just be to use the slope-intercept form. And again, this one we could not use that form directly because this point given was not the y-intercept, it was just another random point. So that was the easiest one to write. Let's look at C and D. Taking a look at parts C and D here, these are different, and in fact, actually they're going to end up being a little easier than the other ones. Notice that y equals 3, that's the equation given. Well, if you remember from before, that's just a horizontal line. Technically the slope is 0, right? So any horizontal line always has the equation y equals a number. Well, if we want to go through the point negative 7, 5, what horizontal line goes through the point negative 7, 5? All that matters is that we have the y-coordinate fixed, right? So y equals 5 is going to be parallel to y equals 3, and that point is going to have to be on it. And that's it. Now this one's really similar, but instead the equation is x equals something. And recall that that means it's a vertical line. And if that's a vertical line, then any parallel line to it must also be of the form x equals a number. But in this case, the number that we want is the x coordinate. So x equals negative 7 will be parallel to x equals 3. They'll both be vertical, but just at different locations. Okay? So that'll do it for this lesson. Again, happy math, and we will see you guys next time.